Alright, we are working on proofs in chapter 5 right now. So this is the 5.3 notes. We talked about all of these last time and how to identify the different types of triangle congruents, and there's 5 different types. So we're going to use these to fill out proofs. Okay, so how this works is if you have not already filled in the givens and what you're trying to prove, go ahead and pause the video and fill that in. I've done that already. And then what we're going to do, we're going to take all these givens and we're going to mark them on these triangles. So it says that AD is congruent to AB. So we're going to mark those with those little tick marks that show congruence. And then we're going to do the same thing for the second given. Okay. Alright. Then we've got to figure out which one of these, listed right here, which one of these 5 can we use to prove that these 2 triangles are congruent. So hypotenuse leg has to be a right triangle. We don't know if this is a right angle. There's no way that we can prove that, so we automatically know it's not hypotenuse leg. And then we've got to figure out, is there a way that we know any of these angles are congruent? Well, first of all, we already know that we have 2 sides, so it is definitely not going to be angle side or hypotenuse leg. It has to be one of these 2 right here, because we have 2 sides that are congruent already, and these 2 are the only ones that follow that. And then there's just no way from the given information for us to figure out that one of the angles are congruent. But what we do know is that this is going to be congruent because it's the same line. These are touching each other. It's a shared line. And so you'll see this a lot over this chapter. And so we have figured out that the 3 sides are congruent for each triangle. And so the way we know that these are congruent is by side, side, side. And that's always going to go across from saying the 2 triangles are congruent. And so you can honestly figure that out first before you do the rest of the proof. So this is a little different than some of the proofs we've done in the past. But we know that the 3 sides are congruent, and that's how the 2 triangles are congruent. And so what I'm going to write over here are these 3 letters, because those are the 3 things we need to prove in order to show that side, side, side shows congruence.
Hardness is irrelevant, but he's really...
Sorry about that. Okay, so we know that this side on each triangle is congruent, because if you separate these, AC on the top triangle is the same as AC on the bottom triangle. So we'll write that. Okay, this is something we talked about quite a few chapters ago, in chapter 2. But we talked about if you have the exact same thing on both sides, then it's going to be the reflexive property. So anytime you have that, anytime you have a shared side, so AC is AC, you write that down, it's going to be reflexive property. We haven't really used that a ton, but you've heard of that word, hopefully. And if not, then that's okay. It also kind of explains it up here. It talks about the reflexive side and reflexive angles or vertical angles, which you can look at if you're confused. Alright, now we are on to the proof. Alright, this first one's given. So we're going to write down everything that's given. We're going to mark it. So it says that AC bisects DAB. So AC cuts this angle in half, meaning they're equal halves. So if this big angle, DAB, is cut in half, we know that this half is equal to that half. So I'm going to put these little arc marks to show that they're congruent. Top angle congruent to the bottom angle. And then we also know that angle 1 and 2 are congruent because that's just simply given. So we are going to mark those congruent as well. Okay. And then we know that we have another shared side, like the previous example. So I'm going to mark that congruent. And we can look at our picture and tell, if I look at my top triangle, say I've got an angle, a congruent side, and an angle. So angle, side, angle. Bottom one, angle, side, angle. So that's how we know that that is our congruence. And it's pretty helpful to, look at the list of 5 of them. There it is. As you are trying to decide. So just FYI, it has to be one of the 5 specific pairs we talked about last time. Alright, now we know that it's angle, side, angle. That's proving that they're congruent. And we can go through and figure out how to prove those things. We've already marked them, so we just need to figure out how we do that. Alright, so we've got to ask ourselves, how did we know to mark DAC congruent to BAC? So this top angle congruent to the bottom one. Well, it's because we knew what the word bisect means. And we knew, since we knew the definition of bisect, we knew that we could mark those 2 congruent. Okay. Alright, and then we want to show that the side is congruent. So how did we know that AC is congruent to AC? Well, it's because it's a shared side. Starts at A, goes to C, so we know it has to be the same. And we talked about that last proof. We know that that's reflexive property. Alright, our last angle that we marked, angle 1 and 2, don't overthink this. It's given. We knew that it was congruent. The reason we were able to mark it congruent is because it is given. Right. So these 2 right here are interchangeable. They don't necessarily have to be in that order. I just put them in that order so that it would be in angle, side, angle order, but it's not wrong if you flip these. Okay? Moving right along. Alright, C is the midpoint of BD, so that's going to be given. We also, it shows that BC is congruent to DC. How do we know that? Well, it's because we know the definition of midpoint. We know that if C is directly in the middle of BD, then it cuts these 2 in half. So we know that those 2 are the same. The reason we know that is because of the definition of midpoint. Alright? Okay, great. Now we've got to figure out how we know the rest of this is congruent. So it says C is the midpoint of AE. So C is right in the middle of AE. So same idea as the first 2. This is cut into equal halves. And so we know that AC is going to be congruent to CE because that segment is cut in half. So I'll go ahead and write the given. So C is the midpoint of AE. And that's given. And the way I was able to mark them congruent, AC is congruent to CE, is because I knew what the definition of midpoint was. I knew that it cuts this segment in half. Alright, so there's one other thing that you always need to be looking for when you have congruent triangles. And that's this little bow tie looking thing that we've got going on. We've got 2 angles right here that are congruent angles. We have to know why they are the same. And this is a word that you've seen a lot this semester. And we keep telling you that it will come up over and over again. It's not going away. You know that these are the same because they are vertical angles. Okay? So if we look at one of our triangles, we will see that we've got a side, an angle in between the side, and then another side. Over here we've got side, angle, side. So that is how we know that those are congruent, those two triangles. And so we have our side accounted for, we are missing our angle. So we have to figure out, how do we write that these angles are congruent? Well, this one is called angle BCA. The B and A are interchangeable. The C has to stay in the middle. That's congruent to angle ECD. So super important that the C's are in the middle. And then how do we know that? We were able to mark those congruent because we knew they were vertical angles. Moving on to the left. Alright, this example is the most challenging example. I went ahead and wrote in the given, so if you haven't done that, pause that and do that real quick. But we are going to go ahead and mark our triangle. So we have HY is congruent to LY, and we know that because it's given. And then we can also write these parallel symbols in, like WH is congruent to FL. The arrows do not mean the sides are equal. Okay? They show that they are parallel. Those are parallel symbols. Do not confuse them for showing they're equal. We do not know that HW is congruent to FL. We do not know that. But something that we do know is that the vertical angles are congruent. We've got another bow tie in there. And then there's a way that we can figure out that two angles are parallel. So this can be a bit confusing, but I just want to point out that we have two parallel lines, and then we have a transversal going through. So from H to L, that is the transversal going through. So if you look at these angles right here, angle H and angle L, you know that they are congruent because they are both inside the parallel lines, because we mark those as parallel, and they are on alternate sides of the transversal. So they are alternate interior angles. Right. You know that they're alternate interior angles because you've already marked that these parallel and they're in between the parallel lines. Anytime it tells you that two angles are parallel, it's going to be one of these angle pairs. Because these do not show that lines are congruent. They show that the lines are parallel, and therefore you can mark the angles congruent. So we have an angle, a side, and an angle. This side is not congruent, so we can't say that. It's an angle, a side in between, and another angle. So we've got angle, side, angle. And our side has already been marked congruent because we know that HY and LY is congruent. One of our angles has been marked congruent. We have one more angle to go. And the way we figured that out was because the angles in the middle and the bow tie were congruent, and those are vertical angles. So angle HYW is congruent to angle FYL. And those are vertical angles. Alright, we're moving on to page 13, which is the level 4 notes. And I'm just going to go through this first proof with you. So we know that these two triangles are congruent because angle, and side So the side's not in between the angle. So it has to be angle, angle, side. But then, because we have proved that these two triangles are congruent, we know that all of the other sides and angles are also congruent. So not just the ones marked. If we prove that these three are congruent to these three, we can also know that the rest are congruent by this thing right here, which is really long, and its corresponding parts of congruent triangles are congruent. We don't really have to remember that. You just need to know that CPCTC acronym. So we already know that these three sides are congruent to these three sides and angles. But what we don't know is that these are also the same. So I'm going to mark these with my different colored pen. And so I'm going to pause this real quick, and I want you to also pause it, and I want you to mark what sides are congruent to what. So like H is congruent to M, and so write the three sides congruent symbols that we filled in. Alright, so pause the video if you haven't marked what's under here. I'm about to show you what they are. So angle H is congruent to angle M. So we're just writing all the ones that we marked. We don't have any other reason to know that they are congruent other than we know this triangle is congruent by angle, angle, side, so all of the sides and angles have to be congruent. That's the idea we're trying to get through here. So we're going to look at this proof. And if you notice, this ends with something different than the earlier ones did. All the other ones ended with triangle blah 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 is congruent to the other triangle. This ends with two angles being congruent. So we go through all the steps we did for the other ones, except we're really just adding one more. So we can mark what it shows are congruent. So it says angle 1 and 2 are congruent, so I'm going to write that down. It also says that AC is congruent to AR, and that is given. Alright, great. And then if we look, we need to look for reflexive sides, or shared sides, and we also need to look for vertical angles. And there just happens to be vertical angles here in the middle. It's like a little bow tie. They're touching. So we can look at this triangle and realize that we have an angle, angle, side triangle. And that's how we know that it is congruent. So we know that we need to prove angle, angle, side. And the reason I'm writing angle next to this is because it's an angle. The reason I'm writing side next to that is because it's a side. So we have to prove that the other angle is congruent. And that will show us that these triangles are congruent. The triangle LCA is congruent to triangle, and these have to match up. S and L. R goes with C, and then A. And we know that they are congruent by angle, angle, side, which we just figured out up here. Alright, and then how did we figure out that this angle right here was congruent? This angle right here? Because when we looked at it, it's one of the things that we always look for at the beginning, is vertical angles. We noticed that they were vertical angles, so we can show that they are congruent. Right? And then we've got angle 3 is congruent to angle 4. So the only way we could possibly know that these two are congruent is because of this little acronym, corresponding parts of congruent triangles are congruent. Because nothing in this statement and nothing on those triangles shows that they're the same. I wish I could write it. Corresponding parts of congruent triangles are congruent. So basically anything that doesn't end with the two triangles, it ends with these two like angles being congruent or those two sides being congruent. It's going to be this CPCTC acronym.